Alright, we're going to let G be a group of order 315, which it turns out is 3 cubed times 13. So let's do our typical n13 is equivalent to 1 mod 3 13. I meant 13, not 3. And the order of n13 also divides 3 cubed, which is 27. So let's see here. We've got 1, got 14, 27, and then obviously that's also 1 and 27 are options for n13. Let's see here. If n13 equals 1, we're done because the collection of p-CELO subgroups is closed under conjugation, and so if there's only one p-CELO subgroup, well, if there's only one CELO 13 subgroup, then conjugating by any element of the group gives you that same CELO 13 subgroup, and so it's normal. And so that's that. So we're here. So anyways, if n13 is 27, then G has 13 minus 1 times 27, which is, if you calculate it, 324 non-trivial elements contained in CELO 13 subgroups. And that's because if you have any two CELO P subgroups where P is if you have two subgroups both of whose orders are prime P, and you consider their intersection, the order of the intersection has to divide the order of both the groups that they came from. So the order of the intersection it's a subgroup, and its order must divide the prime P, and so it must have order 1 or P. If the intersection has order P, then the two groups that you started with were the same. If it's 1, then, well, that's the case we're talking about right here. So the 13 minus 1 here, those are the 12 obviously each CELO 13 subgroup will contain the identity, but then it will contain 12 additional it'll contain 12 additional elements which are unique to that particular CELO 13 subgroup. Okay. So then there are 351 minus 324, which is 27 elements remaining. And so then N3, any CELO 3 subgroup will have order 3 cubed, which is 27. So we can't have more than one such subgroup because we've only got 27 elements left to work from. So if we want to write that out, then that tells us that N3 is less than or equal to 1, and we know that N3 is always going to be great. We know that NP is greater than or equal to 1 for any prime P, and so N3 equals 1. And we're done in this case, because again, this CELO 3 subgroup is stable under conjugation, i.e. you conjugate by any element and you get the same subgroup back. And so, yeah, it's normal. And this completes our proof.